Hello my dear students. Today we are in lecture number 21 of chapter 2 Electrostat. My dear students, today lecture will start with a question, because in last lecture I left you behind the equipotential surface, and we had not solved a simple question that has been asked in a board examination, and you can find in number of books that question. I am B.S. Pandey, student. This is the classwork you have to do, and after this question I'll start today's lecture. Today we will study the potential due to dipole. You have a study already about the dipole. Okay, student. So this is the question. These are the plates, and these plates are maintained at different potential. In this particular question, I'll give you 3 to 4 questions. The one question I'll solve, and then rest question you have to solve by yourself. Suppose a charge Q, it is the given charge Q itself. Okay, I'm not giving the value, 1 coulomb, 5 coulomb, whatever it can be written. So this is the charge Q, and these are the plates which are maintained at -2 volt. Suppose it is 0 volt, 5 volt and 10 volt. The one charge is to move from here to here. So the case A, the same charge is to move. Case A, that is the question A. B, you have to move the charge from here to here. It is the B. The second one, C and D. D. For each question A, B, C and D, you have to find potential difference. Okay, that is VAB. If you are moving from one plate, actually let me write the not find potential, actually you can find work done. If I'll write it to find the potential, that is very easy. Find work done to move the charge from one plate to another. Okay, as given. You have to only move the charge as it is mentioned in the diagram. Okay, my dear student. One question I'm solving, and the rest 3 questions you have to solve by yourself. So this is the solution. The first one, as we know that the formula of work done, it is minus delta U. I hope you remember, and it can be the minus U final minus U initial, and this is also can be the U initial minus U final. U final, and this U is nothing but the Q times V, that is the V initial minus V final. So work done in case A, okay, charge itself Q, V initial. Now this question is very easy, you can solve. V initial, in A it is moving from -2 volt, minus this one V final, so you can see the V final is 5 volt, and this is minus 7Q joule. This is the answer. I hope this is very easy for you. Okay, my dear student. Now this was the question. Actually I was thinking to start today's lecture with this question. Okay, now basically today in lecture we have to focus over the potential due to dipole. You must remember the dipole, It is the system of two equal and opposite charges separated by the very small vector distance. Okay. Now, the first case we are going to derive here the potential due to dipole at axial point. Potential at axial point. Okay, my dear student. This is the positive charge and this is the negative charge, plus and minus. Again, I'm telling you this is the Q and Q. Q is the either charge of dipole, and this is the dipole length. It is 2a. 2a. From center, you have to find potential at distance x. Okay. Over here, you have to find the potential at x, and this is the point P. You have to find the potential at point P, that is Vp. As we know that potential is scalar quantity, as we have solved for the electric field for the dipole case, then we have written the direction of electric field for positive this one and negative this one, but it is very simple. You have to only find the separation between the either charge and observation point, and then you will find the potential. But the V net you must write, it is the V positive plus V negative. Due to the positive charge and negative charge, the net potential will be sum up. It is the scalar quantity. It has to nothing worried about the direction. Okay, my dear student. Now, V positive, it is K Q divided by position. So for the positive charge, the observation point is how much away? This is the x and this is a. If it is 2a, the half distance, it will be a. Okay, it will be a. It means from positive charge, the observation point is how much away? It is a plus x. So it is a plus x, k q by r. This is for the positive charge. Now plus for the negative charge, as we know that for the negative charge we'll use the nature, so it's the minus k q over the distance. Now for the negative charge, the distance will be, since it is x and this will be a, so this distance will be how much? X minus a. X minus a. That's it. Okay, it's completed. Now you have to do a simple mathematical calculation. KQ, it is common. 1 by a plus x minus 1 by x minus a. It is KQ. LCM, you will take here the x square minus a square, x minus a minus x minus a, and you will have this x will be cancel out, so the k q times 2a divided by x square minus a square, and this can be also written as this 2a is the dipole length. You can see it is the dipole length, so this can be written as the q times dipole length is the p, so minus k p by x square minus a square. This is the V net minus kp by x square a square. Now, so what this negative sign signifies? Very good. This negative sign signifies that observation point is near the negative charge and potential of negative charge dominating. That's why we are getting over here negative sign. If we wish to find the potential near the positive charge, it means around this one you will get the sign as positive. Okay, so this is the electric potential due to dipole at axial point. Note down this, students. I'll rub this. Now for the equatorial point. Okay, student, you can write this equation also. This one for the short dipole, you can simplify. This is not very tough, but you should remember for short dipole, you can write this equation at the V at axial point. It is minus Kp by for short dipole, that A was the dipole length, half of the dipole length, which is very less. Here for short dipole you can write the A is much less than x, and this A can be neglected, x square. So minus Kp by x square. Now student, will derive potential, the second case, at equatorial point. So this is the charge, plus and minus. It is the dipole, having the dipole length. How much? It is 2a. At x distance we wish to find potential at this point P, and this is the position, this is the point P. If this is x, this is A, and this will be how much? A square plus x square, and this is also A square plus x square. If you are writing the potential V net, then you have to write the V plus V minus, that is the potential due to both the charge. You have to sum up. It is the vector quantity. Now KQ for positive charge, KQ by position, suppose it is Z, and for this negative charge, for positive charge we have been written the KQ by Z for this one, and for this charge we have to write at this point the potential due to this charge will be KQ by Z again, but here the charge negative, so minus KQ by Z. So the net potential will be how much? It is 0. Remember, net potential at equatorial point must be how much? 0. And if it is 0, then you can say, my dear students, it is equatorial line. Even at equatorial plane you will find any point, you will get the net potential 0. It means between these two charges this plane is equipotential surface. Of course, try to recall, we have drawn equipotential surface for the dipole. For the dipole we have drawn the equipotential surface and we got a common plane. Okay, it was flat near this one, and we have been drawn a flat. You can go back to the last lecture, you can see the equipotential surface. It was the straight, actually this was like a plane I have drawn with the, okay, this was like a plane, and this is the equatorial plane, this plane. At any point you will find the potential is 0. Okay, my dear friend. Now the potential at arbitrary point, that is the very important, and this particular derivation only has given in NCERT. Okay, so give the heading potential due to dipole at, this is the third case, at arbitrary point. This is also termed as the general point. Okay, my dear student. So suppose this is negative charge and positive charge. This is the positive charge and this is the negative charge. There are number of method you can solve this derivation. This is the mathematical derivation. Okay, but I'm telling you the exact method that is given in NCERT. You have to find potential at this point P. Suppose this is R1, this R is given, and suppose this is R2. Okay, my dear student, this is dipole. Dipole length is how much? It is 2a. This is negative, this is positive. With the dipole moment, the direction it is theta given. Okay, if it is theta, this will be 180 minus theta. Net potential we will write V net as V plus B minus. Okay, and what is V plus? It is KQ by R1 plus KQ by R2. But for negative charge here R2, negative charge we are writing, we have to take the nature also. So it is KQ. Overall, we are having the net potential as KQ common 1 by R1 minus 1 by R2. That we have to find. This is the net potential. Now, to find this 1 by R1 and 1 by R2, we have to do mathematical calculation. Okay, my dear student. So, suppose this is the position vector R1, okay, and this is R, and from dipole, since it is the dipole length, suppose this is A. This will be the 2A, so this is A. Could you write using the triangle law? Using triangle law, you can write this is A, this is a triangle, A plus R1 equals to R. Vector A plus R1 is equals to vector R. We have to find R1. So the R1 can be written as, vector R1 can be written as R minus A. Okay, now you have to find the magnitude of R1. As we have studied already, the vector, if it is written the vector A, try to remember vector A plus vector B, then mod of this vector can written the A square plus B square plus twice AB cos theta, where theta is the angle between A and B. If it is mod of A minus B, try to recall, it is A square plus B square minus 2AB. Okay, cos theta. The same we are going to use here. Here the minus, and direction between R and A, you can see this is the direction of A and this is the direction of R. Here the angle is how much? Theta. So we'll write mod of R, that mod of R1, that is R1, it is root under R square A square minus 2AR cos theta. Okay, students? Yes. Now R1 square can written the R square plus A square plus twice, sorry, the minus na, minus twice AR cos theta. Look at carefully the calculations. Okay, the simple error will create a trouble, okay, in lab. So look at carefully the calculation. R1, since this quantity is very small, if we'll find R1 square, here the common, we take R square, it is 1 plus A square by R square minus 2A by R cos theta. Could you write? Since A is very small, dipole length, for short dipole we are obtaining here the formula A is small, and already we are getting a square, so it will be very small, and we are dividing by a denominator which is large. Okay, so this quantity will be very small, we can neglect it. R1 square, it is R square 1 minus twice A cos theta over R. We can write this one. Now, my dear students, we have to put R1 and R2 over here. I've written already. I don't have sufficient space, so I'm erasing this one. So the R1, this one, R1 can be written as root under overall. So the R1 minus 2A cos theta over R 1 by 2. Okay, taking square out, it will be in root under, and R square come out from the root, but it is in root, and that root can be written as 1 by 2. Okay, my dear student. Now 1 by R, we are doing reciprocal. Okay, we are doing reciprocal. This will be the 1 by R. and this will be how much? 1 minus 2a cos theta over r minus 1 by 2. If it reciprocate, then it looks like this one. I'm erasing this one. Now 1 by r1 is 1 by r 1 minus, if this quantity is much less than this one, then we can apply here the binomial expansion. You have studied already in mathematics. If it is the a plus minus b and this a by b is much less than 1, then you can apply this expansion up to the first term and it can be written as minus, and this minus will multiply with this one, it will plus, and 2a cosine theta over 2r. How this 2? This 2 will multiply with denominator and 2 will be cancelled out. Overall we are getting here the 1 by r 1 plus twice a cosine, sorry, here the, let me rub this one, a cos theta over r, this one. Similarly, you can write, my dear student, 1 by r2 is 1 by r 1 minus a cos theta over r. Okay, you can apply the same method to write down. In examination you can write directly. Okay, now we have to put this r1 and 1 by r1 1 by r2 over here to find the v net. Okay, my dear, kq 1 by r1, it is 1 by r is common in both r1, 1 by r1 and 1 by r2, so I'm taking out 1 by r. Now inside 1 by r1, it is 1 plus 2a cos theta by, sorry, over here, a cos theta by r, and minus, so I'm giving you the minus, and this one 1 minus, and minus plus a cos theta by r. So this minus and plus will be cancelled out. Finally we have here, even I can rub this diagram also, v net kq by r times twice a cos theta by r or this q times 2 I can write in the p, so the kp cos theta over this r square. Okay, so the v can be written as the kp cos theta by r square. This is the expression for the potential. Remember, this is the expression for potential at an arbitrary point, that is at any general point. If you are not given the angle, if you will apply the condition over here, you can find the expression for equatorial and axial both. Now here the special case, if this theta is 0, okay, if theta is how much? 0 degree, then this point will move on the axis. Or if this theta is 180, then it will again move on this axis. By putting this 0 or 180, you will get this cos theta, cos 0, either 1 or cos 180 minus 1. Okay, if you are moving 180, then you are going towards the negative charge. If you are putting this theta 0, you are going near the positive charge. If you are going near the positive charge, this is giving you the positive 1. If you are moving towards the negative charge, it is giving you the negative 1, and that will make the result this positive or negative. As I told you, near the positive charge you will get the potential positive, and near the negative charge you will get the net potential negative. So this can be written the v as kp cos theta will be 1 or minus 1. Okay, so I'm writing here the plus minus kp by r square, and this was the same derivation. Try to recall, this was the same derivation you got for the axial. If theta is 90 degree. 90 degree making this 90 degree perpendicular, that is the equatorial plane or the equatorial line, and cos 90 will be how much? It is 0. Then V will be how much? 0. Exactly, we got the answer. So with this derivation, if you remember this derivation, you have asked to derive at axial point or equatorial point, you can use this one also. But I hope this one is little bit lengthy than that. You can derive directly for the axial or equatorial. Okay, my dear students. So this is the potential due to dipole. Now students, the last topic of today, if you will be asked to find the work done to rotate a dipole, okay, work done to rotate a dipole in uniform electric field, how you will find the work done? Okay, suppose this is the uniform electric field in which a dipole is kept. This is the electric field and you have placed a dipole. Suppose this is the minus charge or the plus charge, and you have to rotate this dipole by a very small angle. Then how much work you have to done to rotate this dipole? Okay, so as we know that work done to rotate the dipole, it is a very simple work done. As you know that the torque, it is Pe sin theta, we have already derived, and work done, small work done, can be written as tau d theta. Okay, tau d theta. So the work done will be tau, it is Pe sin theta d theta. Pe is constant, integrating this one from one angle to another angle. The sin theta will be integrated to give minus cos theta. Okay, the integration of sin theta will be how much? Yes, minus cos theta, and it is to rotate from 0 degree to theta. Okay, from 0 degree, this is the dipole moment. If you leave this dipole, it will move in this direction, plus will align here and minus will align here. It means you have to do the work to rotate this dipole in this way. So if you rotate by theta, from which angle you are coming? 0 to theta, then this will be Pe minus cos theta and minus minus plus cos 0. So the work done when it was at 0 degree, you don't have to do work, so work 0. To rotate theta, you have to do the work W, so W minus 0, it will be W, and it is Pe 1 minus cos theta. Remember, my dear student, this is the work done to rotate a dipole for very small angle theta. This is the, if you have to ask, if you leave a dipole from its unstable state, then how much work will be done by the dipole itself? This is the work to rotate the dipole, that is by the external force, but work done by the dipole, it means you have to find the energy, potential energy that has been stored in dipole. Then how you will find the potential energy? In that case, you have to just change the integration limit, my dear student. Okay, how you will change the integration limit? Actually, I'm telling you over here. This will rotate by the certain angle and you will give the certain value. I think I'll discuss this particular topic because in very short time you will not get the proper concept. So I will discuss this in next lecture and you will be able to solve by yourself only. Okay, that is not the very tough. Okay, my dear student, so this is all about today lecture. We have studied about this one. In next lecture we'll start from here only. Okay, what is the potential energy stored in a dipole? Thank you, my dear students.